This is the second part in the Okta Workflow function series. In the first part, I have discussed in depth about a branching function. Now, in this part, I'll be working mostly with the text and sub functions inside the text. Okay, I have the similar setup. I have used my external API for this part, and I'll be doing some modification on the field returned by this API endpoint. Without further ado, let's get started. So the first one in the line is add function. So it will give the specific value at a specific position. So for example, this is the request ID, and we if we want like any value or like any key from the specific position, then we will be using it. I'll show you. So first I need to get this from the object as a request ID, and then just drag and drop. Or if you want something, you can write it down and specify the position as well. I'll be continuing mostly with the response from the API endpoint. So I'll be drag and drop, and let's say like we want to verify the request ID, and the first part or like first keyword need to be like req or request. So I'll specify the position as 0. So for some of those who are new to programming, the count always start at 0. Okay, okay, I will run this flow, and here it gets the first character for the request ID, that is req. Okay, it can be helpful in certain scenario for the identity automation. For example, here the manager has the employee ID. We might want to specify like something from here, or like the country code, or in the best case like the phone number or something like that. So that's all for this part. I'll be moving on the next function. So next function is base64. It will return the base64 encoding of the text string. So if you don't know the base64, I highly suggest the cybersafe. So base64 is like encoding and decoding technique. So you can encode any text as a base64. Just use two base64, and it will encode it. And for those of for all of us like who are in the identity space, you must be familiar with the JWT. So I'll use it jwt.io, and here this JSON web token is encoded on the base64. I can decode it from here. So this is base64 encoded, and I can decode value from here. Okay, that's the introduction for the base64. Now I'll show you how we can use it. So the first part is like we can convert some specific field to the base64. Okay, for example, what I might want to convert. Okay, Let's check the response JSON. Okay, I might want to convert the OAuth context to the base64. So what I can do is I can just get the OAuth context key. Okay, and convert it to the base64, and the underlying function or underlying helper function I can use to decode it, so we can send it as a message on the Slack channel, or we can send it to other API. So I'll run this function and check the result. So this is the base64 decoded value for our JSON response, and I can validate it using the cyber safe. Okay, our input is our base64 and we want to convert it from the base64. So this is the JSON response decoded from the base64. So base64 is not encryption, it's just decoding. So anyone with this value can easily decode or encode to the base64. It does not require cipher or key. Okay, with being said, so I have converted a text to base64, and also we can like convert base64 back to the text. Okay, I'll be adding these value on the response. Okay, for the Alex user, I'll add one key. Okay, this is the good part. Okay, I have added the encoded key. Now we can like decode this value. For that, I need to rerun my server. Okay, now back on the workflow, I can invoke the base64 decode function. I need to remove this and use the key called encoded, and it will decode the encoded base64. So I'll save it and check the flow. Okay, here is the decoded value for base64 encoded. Okay, we might want to use the base64 decoded value if the API, or if the API return us the JSON web token, and we might want to extract some useful value from the JSON web token, such as expiry date, or ID token, open ID, profile, user email, and so on. Okay, moving on to the next function. The next function in line is compose. So if you have watched my previous video, you will see I have used the compose function extensively. So it is a free text field. I can write anything here, so like that. User has Rix label, and I can drag and drop the value here. So this is the power of the text compose. The composed text can be used or forwarded to the other card, where it can be used to send messages on a specific channel or send email to specific users. Okay, this is the output of the text compose. Moving on to the next function. The next function is concatenate. So concatenate will combine a list of text into a single string. Okay, I need to think about the use case for the concatenation. Okay, it's like basically combining a two string into the one. For example, like I can add a random string, or I can generate a UUID. I can generate the UUID and then combine it with the request ID. So this will give me the output of combination of UUID and the request ID. So it basically combine two text into one. So this is now our correlation ID or the request ID. That is the combination of the random UUID and the request ID. So it's highly likely that you will not be using all of those functions, but you need to understand like which one to use when which one is to use when, and like the best functions for our use cases. Okay, moving on to the next is find function. So it sorts for text and return the position. It mentions that it return the position. Okay, I can think of like email. So it can be usable on the email. So if we want to split the username, or like first name last name, and separate it with the email, I can look for the @ character and split the username from that specific character. Or like if I want to find out something on the text. For example, like if I want to find the dot on the text, I can split, providing the dot, and in which position dot this lies on the text. And I have mentioned earlier, every count start with the 0. Okay, first I'll do with the user email, and then so with the username. So here on this Alex Morgan, it the @ string exists on the position 11. So everything start with the 0 and count it toward. Okay, that's good for now. Let's move on to the another function. So this one is the find email. So it will use the regex to find the email. So I can think of like I'll stringify the JSON response and search for the email on the response. So I'll stringify the HTTP body response, and then use the output as the text and search the email on email. Okay, I'll save the flow and check like if uh, if the Okta Workflow is able to figure out the email or not. Okay, here it stringify the JSON response, so it convert the JSON response to the string, and then it sorts for the text on the string, and it find out the email as alexmorgan at example.com. So though the text has multiple email, it return the first match email address. This one is the first match email address, and the other email in this response is the manager email. It should be somewhere. This is the manager email, but it only identifies the one email address. So that's the limitation of the Okta's find email built-in function. Okay, moving on to the next function. This is the find last function, so it is similar to the find. It also returns the indexed, and it sorts for the last match inside the text. So for example, remove this one. Might want to use the username. Okay, I think I can continue with the email. That makes sense. Use email, and I want it with the dot. So there are pretty three dots or two dots on the use email. One here and one here. So I'll I'll save and try to run. What positions does it return? So it returns the last position, that is the 19 from here. So that's what it's supposed to do. Okay, moving on to the next function in line, that is the find pattern, and we can search for the specific pattern in the text as well. So let's try this out. Again, use this. I want to look for the address at the rate, and then it will also return the position as a number. Okay, another one is length, so it will just calculate the length of the string. And the one is the random. Okay, just let's do this. So this will calculate the user email. So we might want to like enforce the length or other part. For example, the best use case is for passport complexity. So if the workflow is setting some user password, and the user input is the password is fed to the Okta workflow, then it can check for the password length and add the if else condition. So if the password is less than the specific or specific or password policy, then the request can be denied. So you can check for the branching video that's on my YouTube channel. And okay, since this response does not have a passport, but we can treat the user email as the password for now. Okay, and this will just calculate the length of the text. So here the length of the text is 23. and we can continue build on that. So if it was a password, then I can go ahead and add a branching function like if else conditions. So if the value of length is less than or equal to 25, then do something. If it is greater than, then do something. Okay, that's the use case for the text length function. Another function in line is a random function. So it generate just a gibberish value or random text value. We can check it. So if I want a 1,000 character random string, then it will generate me some random value. So this can be useful like if we are building some test cases, or like building some API, but we don't know what input it actually exists. So that we can just use some random string or random value. Back on the flow, might wanna explore more. So other inline is replace. So what we can do with replace is it is one of the important text function, because uh, on the Okta's workflow, we might want to replace some value. So for example, this is the user email address, and it consists of example.com. But if we are provisioning it to the Entra or like underlying system, we might not want to use that. We might want to use our company domain email address instead of like external or partner email address. So what I will do is I look for example.com. I look for example.com, and I'll remove it with, and it asks us like to replace in all the instance, and if the replacement is case sensitive or not. Okay, here I have changed the user email address domain. So I will go ahead and run this flow, and that's the our result. So it successfully replaced the email domain. Okay, back on the flow, let's use the other one. Okay, and we can also replace multiple values with the patterns or patterns, so it will be almost similar. So I'll just skip this. And another one is split. So we might want to split uh, something. So for example, like if I have a username like this, I might want to get a first name and last name from the username. So what I'll do is I'll search for the username, drag it, drop it here, and separator will be the dot. So it will give me the array of first name and last name, and I can work on that using the list function, which I'll show you later. Okay, just a minute. It is username, but it's inside the user. So user dot username, and using the user dot username, I I'll run this flow. Here I get the array of user first name and last name. So I can get the first name and last name and set it to a specific value in other card using the list function. So the next in line for the text function is text segment or substring. So substring is like we want some specific part from the whole string. So we don't want a whole string, but we want just a specific value from that string. Then we can use the substring. I'll show you. So this is the username, and I want this is the user email, and I just want like starting from the two indexed. Okay, let's count it. So I just want the last name for this email. Here the email field is dynamic, and here the email field is dynamic. Maybe it's not the good use cases. So I'll search for the one that is more like remains the same. So for example, the external ID or employee ID, this part is almost likely to be same, or the request ID is almost likely to be same. So if I want to get the request ID that is predictable and consistent, I might want to use the text segmentation. So I'll remove this part and use the request ID. And what I want from the request ID is I want just the ID number. This one is for identifier, that's for the year, but this is the request ID. So if I want just this field, I can use of substring and count it out. The count always start at 0. Okay, it should be 9 to 14. Let's see. So I want the ID. I want just ID from the request ID. So I'll save it and run the flow. Here I got the ID from the request ID. So that's the use case for substring or text segment. Okay, another one in line is uppercase and lowercase. So if we want like if the APIs are not consistent in the naming convention or naming standard, but we want to make our workflow predictable, so we want to convert everything to just one case in order to compare those value more accurately. We can use the two lowercase or two uppercase. So for example, the user risk label is already on the lowercase. So if I want to convert it to the uppercase, so to see here, so this is the user risk label, and currently it is on the like it's the lowercase, but let's make some changes. So if it is like some kind of this case, then it will be very unlikely, very unlikely to match against the lowercase. For example, if I want to match it high to high, then it will fail the test, it will fail the condition. So we might want to normalize it and make it on the make it a same case, either lowercase or either uppercase. So I'll be converting it to lowercase first, and so the uppercase, it's almost the same. So I'll use the user risk label and convert it to the lowercase. It's for the comparison to be consistent. So this one is converted to the lowercase, and I can do the same with the uppercase as well. Now it's on the uppercase. So either lowercase or uppercase before we compare anything. That will makes our workflow predictable. Okay, the next in line, I think that's the last one is the trim. So trim will just remove the leading and trailing backspace. So what does it mean by backspace? Is the empty space. For example, let's consider this value as the high. I'll convert it back to high, and imagine that it has some space here and some space there. Okay, so if it has a trailing or leading backspace, then it will not be matched against the specific value that we want to use on this condition. So for that we want to normalize the text and remove any space from that text. So what I can do is go on the risk label and then check on the output. Okay, it removed the trailing space. Okay, I can show you how it fails the if condition if it includes those error. So I might want to check the user risk level to high and save. So if it is a high risk, I want to compose. And if the user risk level is low, okay, so this is without trimming. So I'll save it. Though the user risk level is high, but it has trailing and leading white space, so it should not be considered as the high risk level. Just test it out. Here you can see that the user risk level does not match the high because it consists of the white space. So that's why we might want to trim it. So I will just change the place if I can do. Okay, I now trim those and I'll use this as output. Okay, now we have normalized our output. Then user risk level should be high and it should be blocked. Okay, I'll check it and run the flow. So these are the small nuances that might leads to the edge cases. So make sure make sure to normalize your input either on the uppercase, lowercase, and trim any leading or trailing space if it includes. Okay, I've already discussed about the unique ID. So unique ID generates the UUID that we might want to attach with the request, or that we might want to add or make our request a unique. So that's all for the text part. I will go on one on each of the function categories. So make sure to like, share, and subscribe this video. Happy learning.